So far, we've seen demand and supply separately. In this screencast, we're going to put them together and see part of the magic of this model. I might be a loser, I'm probably a loser, and definitely a geek, but I get off intellectually, if I could say that, on how powerful just a couple of lines in a graph can be. Maybe you'll see some of what I'm talking about in the screencast. Alright, so in this screencast, we're going to be talking about what is called equilibrium, which is a pretty magical thing in economics. Now it's equilibrium that's going to determine the actual price, I'm going to call that P star, and the actual quantity, I'm going to call that Q star, of goods and services. Remember, supply and demand were both hypothetical series of what ifs. They really told us nothing. Demand told us if prices were various prices, how much people would buy, but it didn't tell us what the price or quantity was actually going to be. Same thing with demand. But when you put supply and demand together, you get the actual price and quantity of goods. And that occurs at the intersection of those two curves that we started to draw out in the last two screencasts, supply and demand, which is why we spent the amount of time we did talking about how we graph them out. Now I want you to think of equilibrium as kind of like a scale. Equilibrium isn't good or bad. It doesn't mean prices or quantities are going to be good or bad. Equilibrium simply means that there's some state that the market is eventually going to come to. Like a scale, if you push one side of the scale down, over time it's going to balance out into a particular place. That's how I want you to think of equilibrium. Not as good or bad, but as essentially simply what's going to be. Alright, well let me bring you back to supply and demand schedules. On the left side of the screen you have a demand schedule, series of possible prices, series of possible quantities that people might want to buy of, again, bushels of corn. Notice again the inverse relationship, that law of demand. As the price goes down, the quantity demanded goes up. On the right-hand side of the screen, you have a typical supply schedule. Again, here, a supply schedule for corn. It obeys the law of supply. The price and the quantity supplied move in the same direction, direct relationship. As price goes down, quantity supplied goes down, and vice versa. Well, equilibrium happens at the price where supply and demand are equal. And if you look at these two schedules, there is only one price here where both supply and demand are equal. That's happening at a price of $3. We're going to call $3 P star, the equilibrium price. And we're going to call 7,000 units Q star, or the equilibrium quantity. Now there's a reason it has to be that, and I'll explain that in a minute. But that's what we're looking for. The price where supply, quantity supplied, and quantity demanded are equal. That's equilibrium. It's perhaps a little bit easier to see in a graph. So you'll remember in the last couple of screencasts, we can take these schedules and graph them out into a supply and demand curve. We could do the same thing here. If I took that same data and drew out a supply curve and drew out a demand curve, it would look like this. Now, looking for the price where supply and demand are equal is the same thing in the graph as simply looking to where the supply and the demand curves intersect. That determines equilibrium. Again, in this example, here it's happening at an equilibrium price of $3 and an equilibrium quantity of 7,000 bushels. Now, this is the price and quantity that the market's going to return to. It might move away from this price and quantity for a small amount of time, but just like the idea with a scale, there are going to be forces at work, an invisible hand, that's going to be pushing the price and quantity back to this price and quantity. To see why, imagine that the price were to go up above the equilibrium price. Let's say the price were to go up to $4. Notice that at $4, the quantity demanded, that first yellow point, is 4,000 units. People only want to buy 4,000 units at a price of $4. Notice that at a price of $4, the quantity supplied, that next yellow dot, is 10,000 units. So what's happening is that if the price were $4, producers would produce 10,000 units. Consumers would only buy 4,000 of those units. That would mean that 6,000 units, the difference, would just be sitting there, unbought by anybody. We call that a surplus. You can think of that as too much stuff. And there's going to be a force at work that pushes the price down. Because as those farmers sit there with those 6,000 bushels of corn that nobody's going to be buying, at some point they're going to say to themselves, hey, at $4, nobody's buying this stuff. How are we going to get rid of this corn before it rots? Well, there's really only one thing to do, which is to start lowering the price. And that's going to be the force at work that pushes the price back down to $3. Well, what if the price were to go below $3? Let's say the price goes down all the way to $2. Again, notice what the quantity supplied and demanded are. Here we have a quantity supplied of 4,000 bushels. That's how much producers would produce. At a price of $2, consumers want to buy a lot more. They'd like to buy 11,000 units. So producers will produce 4,000, consumers will buy all of them, and then they'll be sitting around looking for another 7,000 units to buy. We call that a shortage, not enough stuff produced for the given price. And what's going to wind up happening is that consumers are going to start bidding up that price. The consumers that didn't get corn will say to the producers, hey, at a price of $2, I didn't get any corn. I'll pay you $2.20. I'll pay you $2.50. I'll pay you $3 for a bushel of corn. And again, we have a force at work that's pushing us back to equilibrium. So that notice that the equilibrium price clears the market. It's only at a price at $3 where supply and demand are perfectly equal. It's only at a price of $3 where we have no surplus and no shortage. In other words, the perfect right amount of stuff for the market. Notice also that there's no need for the government to come in and tell anybody how much stuff to produce. The market kind of polices itself. It gets rid of surpluses and gets rid of shortages by pushing that price back to equilibrium either through the actions of consumers or producers. Again, magical forces, invisible hands, making things a certain way in the market. Now that's what equilibrium is, but more importantly than that, there's power to this model because it allows us to make predictions about what's going to happen in the future. One of the things the model is going to allow us to do is make predictions about what's going to happen to P star and Q star. What's going to happen to the price and quantity of goods should something change in the market? This is a big part of economics and the AP exam. Here's where we're going to see a lot of the concepts that we've already seen start to be put together. Alright, so there's a method to this, and I suggest you follow this method. If you could shortcut it in your brain, great. If not, if you follow this method, you'll probably go right most of the time, if not all the time. First, if you're given a piece of information about a market, you have to decide whether it's demand or supply that's being affected. Is it going to change how much consumers want to buy the product, demand, or is it going to change how easy or hard it is to produce the product? That's going to affect supply. Secondly, once you know whether it's supply or demand, you have to decide whether it's increasing or decreasing. And you have to go back to what you learned about determinants of supply and demand to do that. You're going to graph out the change, and then you're going to simply see in the graph what happens to P star and Q star. Alright, let me give you an example, relatively simple one. What if I told you we were talking about the market for Frisbees, and I tell you that the demand for Frisbees has increased? So here I'm making it easy. I'm telling you its demand. You don't have to figure out its demand. I'm also telling you that it's increased. So I've kind of done the first couple of steps for you. If I tell you that the demand for Frisbees increased, can you determine what's going to happen to the price of Frisbees and what's going to happen to the quantity of Frisbees? Equilibrium, price, and quantity. Well, again, the way to do it is to start out with a simple supply and demand curve. We know that supply curves tend to have the upward sloping shape. Demand curves tend to have the downward sloping shape. If demand increases from the first screencast, we know that that's a shift of the demand curve to the right. Now notice what happened to the equilibrium price and quantity. Notice what happened to the new intersection of supply and demand. If the demand for Frisbees increases, we can expect that the price of those Frisbees is going to go up. Look at what's happening to P star. We can also expect that the equilibrium quantity is going to go up as well. And that makes sense. If people want Frisbees more, they'll probably have to pay more for them, and there'll be more of them. Alright, well that one was kind of easy. Let's see if you could try these. What's going to happen to the price and quantity of Frisbees if demand decreases? See if you can graph it out and get the answer. Now start over. What if I told you that supply increases? Start over again, and what if I tell you that supply decreases? Here are the answers. Did you get these? If not, come on in and I'll help you out. All right, those were relatively easy because it was you were told whether it was supply or demand that was moving. Let's try this one. What's going to happen to the price and quantity of frisbees if it's discovered by scientists that frisbees cause heart disease and scoliosis? Why they would, I don't know, but let's assume that they will. Well, here I'm not telling you whether it's supply or demand. You have to figure it out, and you also have to figure out whether it's going to increase or decrease, like I said. All right, well, in this example, it's demand that's going to be affected. Learning that frisbees cause diseases is going to change our tastes or preferences for frisbees, and it's probably going to make us want to buy them less. So once you know that, you're simply going to be shifting the demand curve to the left. That's a decrease in demand. And you can make a prediction about what's going to happen to the price and quantity of frisbees. It's probably what you intuitively thought, but when you graph it out, you can confirm that for yourself. Equilibrium price of frisbees is going to drop from P star to P star 1. The equilibrium quantity is going to drop as well from Q star to Q star 1. All right, now sometimes both the demand curve and the supply curve can shift, and these are harder problems. For example, what if I told you that consumer incomes have risen, so everyone's gotten wealthier, and that frisbees are normal goods? And what if I also told you that independently, a new technology has made production of frisbees both easier and cheaper? Can you predict what's going to happen to P star and Q star, equilibrium, price, and quantity? Well, let's think about each of these shifts individually. If frisbees are a normal good, an increase in incomes will increase demand. P star would rise and Q star would rise. So if that's all that was happening, we can definitely say something about P and Q. What about the other effect? That new technology is going to make it easier to produce frisbees, and it should shift the supply curve to the right. Go back to the last screencast. If the supply curve increases and shifts to the right, the price of frisbees will likely drop, and the quantity of frisbees produced and sold will probably go up as well. Well, we have two different things going on here, and so it can kind of get confusing to see what's going to happen. The demand effect is making P and Q go up. The supply effect is making Q go up, but it's making P go down. The answer as to what's actually going to happen is a bit complicated because it depends on the size of the shifts. If we have a relatively small demand curve shift to the right and a relatively large supply curve shift, like I'm showing here, well, it looks like price is going to go down and quantity is going to go up. On the other hand, if the demand curve shift was very large and the supply curve shift was very small, we might get a different outcome. So how do you deal with these? Well, Dimauro, Reynolds to the rescue. One of the smartest students I ever had about 4 or 5 years ago. I was teaching this, and I was doing a relatively bad job, to be honest. And this kid comes up and said, basically, you're an idiot. I have a much better way of teaching this as opposed to drawing out these different size shifts and trying to figure out what's going on. So I labeled this method after him. That's him. The Dimauro-Reynolds method says, set up a table that looks something like this. Then analyze each shift independently, the effect on demand and then the effect on supply. If you get the same result as a result of each of the shifts for P and Q, you definitely know what's going to happen. If you get different results, you're not exactly sure what's going to happen. So what we saw is that the demand shift made price go up and quantity go up. The supply shift made price go down and the quantity go up. So the net effect in terms of price is indeterminate. We simply don't know. It depends on the size of those shifts. Demand's making price go up, but the supply effect is making price go down. On the other hand, for quantity, we definitely know what's going to happen. Both the demand impact and the supply impact are pushing quantity up. So the answer to this question is that the effect on price is indeterminate. It depends on which effect is larger. But the effect on quantity can be determined pretty easily, quantity is definitely going to go up. All right, if you want a little bit more practice with this, you could try these out. What's going to happen to the price and quantity of Frisbees if each of these next four things happens? And for each one, start over with a new supply and demand curve. See if you could use the Dimauro-Reynolds method to figure out what's going to happen to price and quantity. If you have trouble getting to the answers you're about to see, come on in and I'm happy to help you out. Okay, next time.